As we gaze into the dome of what is the night sky, one cannot help but wonder, how many cliches are there about outer space? There are likely thousands. We speak of the vastness of the universe. We like to constantly remind ourselves of our inability to process the distances that exist in this intergalactic void, the staggering expanses of the unknown. And my personal favorite, are we alone in the universe? Well, you're in luck. I have the answer. None of us will ever again endlessly wonder about this ancient and yet ever-present mystery. Are there beings in other worlds? Do strange entities of shape and thought inhabit planets beyond our reach? Is the universe populated by colonies of creatures walking, crawling, or swimming through unknown collections of intergalactic molecules? Absolutely. To even suggest that we are somehow alone in this cosmos is not only remarkably arrogant, but mathematically outrageous. Our own galaxy, the Milky Way, is relatively small as galaxies go. This microscopic corner of the universe holds an estimated 100 to 400 billion stars. That's a pretty broad estimate. That's as close as we can get, 100 to 400 billion. So let's just go with 250 billion. Our solar system has 8 planets. 9 if you still have an affection for Pluto, but let's go with 8. So, assuming 250 billion stars, that would be an approximate 2 trillion planets, assuming an average of 8 for each star. Even if life only occurred on every 10,000th planet, that would give us 200 million inhabited planets in just our galaxy. 200 million inhabited planets is a lot. We don't even need to travel to any of the other millions of galaxies in the known universe to take a second look. We can start with these 200 million Roswellian neighbors that are right here in our own galactic backyard. The likelihood of life elsewhere in the cosmos, or what we could qualify as life, is quite honestly a given. The improbability lies in the likelihood of even remotely similar conditions. Even on our own planet, one could separate the land and the water creatures as environmental opposites. Comparing fish to land animals, for example, one group thrives surrounded by liquid and the other is surrounded by gas. Each group requires a hyperspecific state of matter for existence. The Jovian gas giants, Neptune, Uranus, Saturn, and Jupiter, are worlds dominated entirely by extreme atmospheric pressures and infinitely violent winds. These planets are likely uninhabitable. There exist approximately 12 terrestrial planets or moons in our solar system. A terrestrial planet becomes a possibility for life since it has a solid surface to stand on. Comparing our 2 closest neighbors, Venus and Mars, both have atmospheres comprised primarily of carbon dioxide. Venus's atmosphere is over 90 times as dense as Earth's and is choked by a runaway greenhouse effect that maintains surface temperatures approaching 900 degrees Fahrenheit. While the planet itself is very close in diameter to ours with similar gravity, the atmospheric pressures and temperature conditions are beyond extreme. Mars, on the other hand, also has a predominantly carbon dioxide atmosphere. However, the pressure is less than 1% of what we have here on Earth. Since the atmosphere is so thin and lacks an ozone layer, Mars has virtually no protection from cosmic rays. Mars is also missing a magnetosphere, a magnetic shield of sorts that works here on Earth to deflect dangerous solar radiation. These and many other missing environmental elements on Mars make conditions for life as we know it effectively impossible. So let's take a quick pass by Titan, the largest moon of Saturn. As we enter orbit around Titan, it actually looks pretty inviting. Appears to be a nice sunny day down there on Titan's surface. We can see there's an atmosphere, land to walk on, and sparkling blue lakes. The drawback is the atmosphere is mostly nitrogen, the surface temperature is a balmy minus 290 degrees Fahrenheit, and the azure blue lakes and rivers are filled with liquid methane. So as you can see, even comparing a few of our local neighbors, the variable nature of interstellar conditions are infinitely vast. Consider this for a moment. Of all of the planets and the moons in our solar system, our Earth has a peculiar distinction. It is the only planet where one can stack up a pile of wood and set it on fire. No other planet in the solar system offers the unique conditions for the very essence of flame. The existence of wood, first of all, and secondly, free oxygen. One would think that free oxygen to make fire would be quite common in the universe, but even here in our own solar system, it's quite rare. The probability of intergalactic life is a gift of the obvious. However, the possibility these beings share even the slightest similarity of planetary conditions is effectively non-existent. Here is a deck of cards with one card representing each of the known elements. Shuffling the cards bearing each of the elements and dealing a hand that equals the composition of our Earth is 1 in a million. Dealing that hand twice is the impossibility. Attempting to deal a hand of even remotely similar elemental conditions coupled with a similar gravitational value and surface temperatures is borderline nonsense. If we also had a deck of cards with random planet sizes yielding different gravitational forces, and another deck was a selection of random distances from a host star, the chances that one could deal a hand of elements coupled with other similar planetary conditions, shuffle the decks and deal the same hand again would be nearly impossible, even in a universe with a scale as vast as ours. We do not question the existence of life. We question the existence of thought. That is really what we are hoping to find. A mirrored interstellar perception of one's existence. Just as a waterborne creature finds difficulties surviving in a gas environment, and a land-based creature surrounded by gas cannot survive in a liquid, with the exception of air-breathing sea creatures, the probability of an interstellar being that has evolved in a wildly different chemical, gravitational, and thermal world could possibly withstand Earth's mixture of gases, chemicals, and liquids is effectively non-existent. Creatures that live at the bottom of our own oceans don't stand a chance when brought to the surface. For them, this deadly transition is merely a pressure change. Never mind the wild chemical differences and conditions that must exist on another planet in some faraway corner of the cosmos. If these imagined creatures were to somehow intercept our transmissions and subsequently decide on a visit, upon arrival and departing their craft, death would be instantaneous. If you consider the diversity on this planet, the creatures in this world range wildly in design. Most mammals are really pretty close as far as basic construction. But once you derail into the world of the cephalopods, which are octopus and squids, the rules change completely. The selection here is really quite vast. Octopus are not only highly intelligent, made easier by the brains in their arms, but can change color and their skin can change texture. Insects are quite another matter, taking on shapes and behaviors far outside of our perception of what is considered reasonable. Once you process the diversity on this planet and consider the conditions that likely exist elsewhere in the universe, you can see that an alien that looks like this is really quite absurd. Is that it? a slightly short guy from another galaxy, I would expect that if one were to embark on a journey of this magnitude, you would think to bring a jacket or maybe some pants. Life does exist on other worlds, and the resulting creatures are going to be as outrageous as the conditions from which they came. Since traveling these ridiculously vast distances would require blistering speed, speed itself becomes the enemy. Einstein's theory of relativity, everyone's favorite E equals mc squared, infers that mass approaching light speed transforms into energy. And, unfortunately, the time we rely on for our reference of existence actually warps the closer we approach the speed of light. So, either these aliens work within the confines of these parameters and travel over hundreds or even thousands of years, or they make their way between galactic destinations through some kind of wormhole that would conveniently bypass the necessity for speed or movement and arrive in various locations free of a spaceship housing fancy equipment. Our friendly aliens would simply move through some kind of glowing tube and arrive elsewhere in an instant. If this option were available, one would not need a ship. No controls or buttons, no doors or windows, and no outer container. If an advanced being possessed such technology, I highly doubt they would even have the slightest interest in striking up a conversation with one of us. If this is really the alien, and this is actually the ship, the only logical conclusion is that they are already here. If an alien looks like this and is flying a ship that can only slightly outperform our best aircraft, a civilization that could produce this type of equipment and remain a mystery to us only needs two things. First, technology that is only slightly more advanced from ours, and secondly, the ability to stay out of sight. You don't need light speed, wormholes, or interstellar machines. Only 100 years ago, a jet aircraft passing overhead would have caused a panic, and yet today, we frequently sleep through the in-flight movies since we've seen this one already. A similar species with marginally better flying machines could hide from us pretty easily. We are discovering new species all the time. New multicolored salamanders, fish, and bugs. However, actually finding a slightly more advanced parallel civilization created by a slightly more advanced creature on this planet would be nearly impossible, especially if they've got some really slick flying machines and they don't want to be found.